Hi everyone, this is the triple trophic levels and biomass question that we're going to go through now. Okay, so the first thing that you've got is a graph question. It's not your usual graph because you are drawing a pyramid of biomass. Okay, so a food chain is shown for organisms in a river. The biomass of the organisms at each trophic level is shown underneath. You need to draw a pyramid of biomass for the food chain in figure 1 on figure 2. So you need to draw this biomass pyramid on this graph paper here. So you should use a suitable scale, label the x-axis and label each trophic level. Okay, so if I'm making a pyramid of biomass, that means that my different creatures are going to be on top of each other up the y-axis, which means the amount of biomass, so my biomass in grams per metre squared is going to be along the bottom. So your first mark is for labelling the x-axis correctly, so it's in biomass in grams per metre squared. My biomass goes all the way to 840, but I'm going to have equal amounts of biomass on either side of this zero, so I'm going to need 420 going this way, 420 going that way. So I need to work out a suitable scale. Okay, I also need to make sure that I can fit 10 on this scale as well, and it's visible and easy to work out whether I've got it right. So the first thing I would do is work out whether I could do 10 by using a full box. So if I was going to use a full box here, it would be 5 on either side, so each small box would be worth 5. So that would be 5, 10, 15, 20, 25. So each large box would be worth 25, 50, 75, 100, 125, 150, 175, 200, 225. Now, like I said earlier, I need to go up to 420, so that's not going to fit. So I'm going to need to make it slightly bigger, so I'm going to have to make each box be worth 10. So that would be 10, 20, 30, 40, 50, 50, 100, 150, 200, 250, 300, 350, 400, 450. So that works out much better, so I'm going to go up in 50s. So I've got 50 this side, all the way up to the end. Now I know this is a really strange graph and you might not have seen one like this before, but if you are doing a pyramid of biomass, you need to be making a triangular shaped graph with equal amounts of biomass on either side of the zero line. So I need to do the same thing again this way, so 50, 100, etc. because we're going to have equal length on both sides. So your second mark would be for doing an appropriate scale, so this would be an appropriate scale. So using this scale, each box, each little tiny square here is worth 10 and each larger box is worth 50. So on the bottom I'm going to put my algae's biomass, okay, because that is my producer. The biomass is 840, so I'm going to need my bar to go 420, sorry, it's twice I've done that, 420 either way. So 400 here, each small box is worth 10, so 420 is that. I'm going to do the same thing on this side, and then I am going to use a ruler to join that line up. Okay, so that is my first bar. Your second bar, so the second one is invertebrate animals, goes up to 200, so I need to go to 100 either side, which is here and here, and join that up. My third is small fish, which is 40, so I need to go 20 either side, so that's 2 small boxes. And then my last one is large fish, which is 10. So each box is worth 10, so I'm going to need to do half to do 5 on either side. So I'm just going to do that freehand because I think I'll be able to do it a bit better. Okay, so far I've got a mark for correctly labelling my x-axis. I have a mark for my scale, my appropriate scale. No, I don't, sorry, I have 1 mark for both of those things. So your appropriate scale and biomass being labelled is 1 mark. My next mark is for all my bar widths being correct. I get 2 marks for that. You get 1 mark knocked off if one of your bars is out by more than half a square. And if you've got more than one that's out by half a square, you don't get any marks for the bars being correct. Okay, and then the 4th mark is for all 4 bars being correctly labelled. So I need to label these bars. This one here as algae, this one as invertebrates, this one as small fish, and this one as large fish. It doesn't matter where you put your labels as long as it's clear where they are. It doesn't matter whether you label them outside or inside, as long as you've got a label that makes them clear. You could also have labelled them as trophic levels. So if you'd label it as trophic level 1, 2, 3, 4, and you could also have labelled it as producer, primary consumer, secondary consumer, tertiary consumer. That would also have been fine. The next thing it asks you to do is calculate the percentage of biomass lost between the algae and the large fish. So to calculate change in percentage, you need the change of value divided by the total value times by 100. So it's gone from 840 to 10, so the change in value is 830. The total biomass value was 840. So I need to do 830 divided by 840, which gives me 0.98. Times by 100 gives me 98.8, which I'm going to round up because it's told me to do 2 significant figures to 99. Okay, you calculate in percentage, so it's 99%. Okay. Your next question is saying, give one way that biomass is lost between the trophic levels. So why is the biomass not preserved from all the algae? Why, when the algae is eaten by the invertebrates, which are eaten by the small fish, are eaten by the large fish, why is there not the same amount of biomass? Okay, so you can lose biomass in a multitude of ways. So you could say inedible parts. So there are parts of the algae and parts of the fish that aren't edible, so that biomass isn't carried through the food chain. You could have said things are lost, so biomass is lost by feces, which is also a way a biomass is lost, and you could have said lost through respiration as CO2. So some of the carbon is lost as CO2 through respiration. So any of those answers are absolutely fine. Your last question, which seems really, really large, but it's quite simple. It says, a large amount of untreated sewage entered the river, many fish died. Untreated sewage contains organic matter and bacteria. So explain why many fish died. So you've got the organic matter and you've got the bacteria. So the bacteria break down organic matter. It's why things rot and decay. Okay, so you're going to get your first mark for saying that bacteria decays organic matter. You could have also said that the bacteria decays the sewage, or bacteria decays the dead plants, or anything that they might find in the water with the fish. Okay. You also need to add that it's by digestion. So when it decays the organic matter, it's by digestion, so it digests the organic matter. So if you've put the bacteria digests the organic matter, that would be 2 marks straight away. Okay. To get the energy to do this, bacteria need to respire. So to digest, they need energy, and to have energy they need to respire. When they respire, they use up oxygen in the water. Which means there's less oxygen for the fish. There's less oxygen for the fish, the fish can't respire as much, which lowers the amount of energy they have. So lower energy supply for fish. Which causes the fish to die. Okay, so the bacteria decay the matter by digestion. Bacteria need energy to do this, which means they need to respire. To respire, they need to use up the oxygen in the water. If they use up the oxygen in the water, there's less oxygen available for the fish, which means the fish don't have the appropriate energy supply to keep them alive, which means they die. Alright, thank you very much.